Welcome friends. In this module, we discuss more problems on Bayes theorem. First of all, let us recall the Bayes theorem that we already discussed. Bayes theorem. If an event A can happen if and only if one or the other of a set of mutually exclusive events B1, B2, etc. Bk happens, where P of Bi not equal to 0 for I equal to 1, 2, etc. n, then P of Bi given A equal to P of Bi into P of A given Bi divided by summation I from 1 to k P of Bi into P of A given Bi for I equal to 1, 2, etc. k. Next, we consider more problems arising from various situations that can be solved using Bayes theorem. Problem 1. Two boxes contain respectively 3 red, 2 black balls and 2 red, 8 black balls. A fair coin is tossed. A ball is to be drawn from any of these boxes according to the toss of the coin. If the coin shows head, a ball is taken from the first box, and if the coin shows tail, a ball is taken from box 2. Finally, a red ball was chosen. Find the probability that coin was resulted in head. Solution. Let B1 and B2 denote the event of occurrence of head and tail respectively when the fair coin is tossed. Let A be the event of getting one red ball. The event A happens only through the events B1 or B2. That is, if the coin shows head, the red ball will be from the first box, and if the coin shows tail, the red ball will be from the second box. Since the coin is fair, P of B1 equal to 1 by 2 and P of B2 equal to 1 by 2. If B1 happened, then the probability of the happening of the event A is the probability of getting a red ball from the first box, which is P of A given B1, that is equal to 3 divided by 5, because box 1 contains 3 red and 2 black balls. If B2 happened, then the probability of the happening of the event A is the probability of getting a red ball from the second box, which is P of A given B2, that is equal to 2 divided by 10, because box 2 contains 2 red, 8 black balls. It is given that the event A has happened. Hence, by Bayes theorem, the probability that coin was resulted in head is P of B1 given A, that is equal to P of B1 into P of A given B1 divided by summation I from 1 to 2 P of Bi into P of A given Bi. That is, P of B1 given A equal to 1 by 2 into 3 by 5 divided by 1 by 2 into 3 by 5 plus 1 by 2 into 2 by 10, that is equal to 3 by 4. Problem 2. Each of the 3 jewelry boxes has 2 drawers. In each drawer of the first box, there is a gold watch. In each drawer of the second box, there is a silver watch. In one drawer of the third box, there is a gold watch, while in the other, there is a silver watch. One box is selected at random, opened one of the drawers, and it contains a gold watch. What is the probability that the other drawer also has a gold watch? Solution. Let B1, B2 and B3 denote the event of selecting the first, second and third jewelry boxes respectively. Let A denote the event of having a gold watch in the first drawer of the box selected. All the 2 drawers of the first box only contain gold watches. Hence, the required probability is the probability of the first box had been selected. That is to find P of B1 given A. Since the boxes are identical, P of B1 equal to P of B2 equal to P of B3, that is equal to 1 by 3. Since the first box contains only gold watches, the probability of getting gold watch from a drawer of the first box P of A given B1, that is equal to 1. Since the second box contains only silver watches, the probability of getting gold watch from a drawer of the second box, that is P of A given B2, that is equal to 0. Since the third box contains gold watch in one drawer and silver watch in the other, the probability of getting gold watch from a drawer of the third box, that is P of A given B3, that is 1 by 2. By Bayes theorem, P of B1 given A equal to P of B1 into P of A given B1 divided by P of B1 into P of A given B1 plus P of B2 into P of A given B2 plus P of B3 into P of A given B3, that is equal to 1 by 3 into 1 divided by 1 by 3 into 1 plus 1 by 3 into 0 plus 1 by 3 into 1 by 2, that is 1 by 3 divided by 1 by 3 plus 1 by 6, that is 1 by 3 divided by 3 by 6, that is 2 divided by 3. Next, problem 3. An insurance company insured 3000 scooter drivers, 2000 car drivers and 5000 truck drivers. The probability of accident by the drivers of these type of vehicles is 0.04, 0.02 and 0.03 respectively. One of the insured people meets an accident. What is the probability that he is a truck driver? Solution. Let B1, B2 and B3 denote the events that the insured person is scooter driver, car driver and truck driver respectively. Let A denote the event of accident. The probability that the person met with the accident is a truck driver is denoted by P of B3 given A. By Bayes theorem, P of B3 given A equal to P of B3 into P of A given B3 divided by P of B1 into P of A given B1 plus P of B2 into P of A given B2 plus P of B3 into P of A given B3. Total of 10,000 people are insured. Hence, probability of insured person is scooter driver, that is equal to P of B1, that is 3000 divided by 10,000, that is 0.3. Probability of insured person is car driver, that is P of B2, that is 2000 divided by 10,000, that is 0.2. Probability of insured person is truck driver, that is equal to P of B3, that is 5000 divided by 10,000, that is 0.5. Probability of scooter driver to met with accident, that is P of A given B1, that is 0.04. Probability of car driver to met with accident, that is equal to P of A given B2, that is 0.02. And probability of truck driver to met with accident, that is P of A given B3, that is 0.03. Hence, P of B3 given A equal to 0.5 into 0.03 divided by 0.3 into 0.04 plus 0.2 into 0.02 plus 0.5 into 0.03, that is 15 divided by 31. Problem 4. In answering a question on a multiple choice test with 4 choices, an examinee either knows the answer with the probability 0.4 or he guesses with the probability 0.6. Let the probability of answering the question correctly is 1 for an examinee who knows the answer and 1 by 4 who guesses. Suppose an examinee answer a question correctly. What is the probability that he really knows the answer? Solution. Let B1 and B2 denote the events that the examinee knows the answer and he guesses the answer respectively. Let A denote the event of answering the question correctly. If the examinee answered correctly, the probability that he really knows the answer is denoted by P of B1 given A. By Bayes theorem, P of B1 given A equal to P of B1 into P of A given B1 divided by P of B1 into P of A given B1 plus P of B2 into P of A given B2. It is given P of B1 equal to 0.4 and P of B2 equal to 0.6, also given P of A given B1 equal to 1 and P of A given B2 equal to 1 by 4. Hence, P of B1 given A equal to 0.4 into 1 divided by 0.4 into 1 plus 0.6 into 1 by 4. So, it is equal to 8 divided by 11. Next, problem 5. There are two unbiased coins and one biased coin with the tail on both sides. A coin is chosen at random and tossed 3 times. If tail occurs all the 3 times, what is the probability that the biased coin has been chosen? Solution. Let B1, B2 and B3 denote the events of choosing the first, second unbiased coins and the third biased coin respectively. Let A denote the event of getting tails in all the 3 tosses. When tail occurs all the 3 times, the probability that the biased coin has been chosen may be denoted by P of B3 given A. We know by Bayes theorem, P of B3 given A equal to P of B3 into P of A given B3 divided by P of B1 into P of A given B1 plus P of B2 into P of A given B2 plus P of B3 into P of A given B3. Here, one coin is selected at random among the 3 coins, hence P of B1 equal to P of B2 equal to P of B3 all are equal to 1 by 3. If the first unbiased coin is selected, the probability of getting tails in all the 3 tosses is P of A given B1, that is 1 by 2 all cube, that is equal to 1 by 8. If the second unbiased coin is selected, then also probability of getting tails in all the 3 tosses is 1 by 8. This is denoted by P of A given B2, that is 1 by 2 all cube, which is equal to 1 by 8. But if the third biased coin is selected, it is sure that all the 3 tosses will result in tails, and then we can write P of A given B3 equal to 1. Now, by Bayes theorem, the required probability, that is P of B3 given A, that is equal to 1 by 3 into 1 divided by 1 by 3 into 1 by 8 plus 1 by 3 into 1 by 8 plus 1 by 3 into 1, that is 1 by 3 divided by 10 by 24, that is equal to 8 divided by 10. Next problem. A balanced die is thrown once. If a 2 appears, a ball is drawn from the first box, otherwise a ball is drawn from the second box. First box contains 4 red, 3 white and 3 black balls. Second box contains 6 red, 2 white and 2 black balls. Find the probability that first box was used given that a red ball was drawn. Solution. Let B1 and B2 denote the events of selecting the first and second boxes respectively. Let A denote the event of getting a red ball. Selections of the boxes for drawing a ball are according to the toss of a balanced die. If 2 appears, first box is selected, otherwise second. Hence, P of B1 equal to 1 by 6 and P of B2 equal to 5 by 6. First box contains 4 red balls out of 10 balls. If first box is selected, the chance of getting a red ball, that is P of A given B1, that is 4 divided by 10. Second box contains 6 red balls out of 10 balls. If second box is selected, the chance of getting a red ball, that is P of A given B2, that is 6 divided by 10. By Bayes theorem, required probability P of B1 given A, that is P of B1 into P of A given B1 divided by P of B1 into P of A given B1 plus P of B2 into P of A given B2, that is equal to 1 by 6 into 4 divided by 10 all divided by 1 by 6 into 4 by 10 plus 5 by 6 into 6 by 10, that is 4 divided by 34. Next problem. A man is known to speak truth 4 out of 5 times. He throws a balanced die and reports that number obtained is 5. Find the probability that the number obtained is actually 5. Solution. Let B1 and B2 denote the events that the number obtained is 5 and the number obtained is not 5 respectively. Let A denote the event of getting the number 5. Since the die is balanced, P of B1 equal to 1 by 6 and P of B2 equal to 5 by 6. P of A given B1 denote the probability of the man to announce the number 5 when it actually appeared. That is the probability of the man to speak truth. Hence, P of A given B1 equal to 4 divided by 5. P of A given B2 denotes the probability of the man to announce the number 5 when some other number is actually appeared. That is the probability of the man not to speak truth. Hence, P of A given B2 equal to 1 divided by 5. When it is reported that number obtained is 5, the probability that the number obtained is actually 5 is denoted by P of B1 given A. By Bayes theorem, required probability P of B1 given A equal to P of B1 into P of A given B1 divided by P of B1 into P of A given B1 plus P of B2 into P of A given B2, that is equal to 1 by 6 into 4 by 5 divided by 1 by 6 into 4 by 5 plus 5 by 6 into 1 by 5, that is equal to 4 by 9. This module is an extension to the previous module. Here we discussed more problems which can be solved using Bayes theorem. A better understanding of the problem solving using Bayes theorem is intended by this module. Before we attend the next session, please try to answer the following questions. A factory has 3 machines producing 20%, 35% and 45% of the total requirements of bolts per day. The machines produce respectively 1%, 1.5% and 2% of defective bolts. A bolt is chosen at random and found defective. What is the probability that it was produced by the second machine? An entomologist spots what might be a rare subspecies of beetle due to the pattern on its back. In the rare subspecies, 98% have the pattern. In the common subspecies, 5% have the pattern. The rare subspecies accounts for only 0.1% of the population. How likely is the beetle having the pattern to be rare? Next problem. In a society, the probability of a person having HIV is 0.006. A test for HIV yields either a positive or negative result. Given that a person has HIV, the probability of a positive test result is 0.99. Given that a person does not have HIV, the probability of a negative test result is also 0.99. Find the probability that a person actually has HIV given that the test is positive. Next, each bag in a large box contains 25 bulbs. 3/4 of the bags are of type A containing bulbs of 20 green and 5 yellow. 1/4 of the bags are of type B, contain bulbs of 10 green and 15 yellow. A bag is selected at random and one bulb is drawn. What is the probability that it is a green bulb? If it is red, what is the probability that a bag having 10 green and 15 yellow bulbs was selected. The books for your reference are Introduction to Probability Models, Sheldon M. Ross, Academic Press, 1997. Introduction to Mathematical Statistics, S. C. Gupta, V. K. Kapoor, Sultan Chand and Sons, 2003. A First Course in Probability, T. K. Chandra, D. Chatterjee, Narosa, 2003. A First Course in Probability, Sheldon M. Ross, Pearson Education, 2007. Probability and Statistics for Engineers, R. A. Johnson, PHI, 2005. Thank you for watching this session. Hope this session was beneficial to you. See you next time. Until then, goodbye.